Now our last problem in Chapter 3 for the makeup exam is, or to prepare for the makeup exam, I should say, 3.23. In a family of 5 children, what is the probability that part A is all are males? So all are males. So for this one, we can use that formula, right? So what is that formula? N prime over S prime T prime, and we're multiplying that by a variable A raised to the S and a variable B raised to the T. And A is going to be the probability of event 1. B is the probability of event 2. S is the number of times event 1 occurs. And let's say T is the number of times event 2 occurs, and N would be the total number of outcomes here. Or total number of events. So in this case, we are looking for 5 males. So what is the probability of that? So for N, we're gonna call N 5. S is, say, the probability of a boy being born here. So we're gonna put a 5 in there. And these are factorials. I'll explain those in a second. T is for girls, and in this case, we're not looking for any girls. So 0 factorial. We're gonna multiply. We're gonna assume having a boy, the probability of having a boy is 1/2, and the probability of having a girl is 1/2. So let's say A is for boy, so 1/2 raised to the 5th versus 1/2 raised to 0. And now we just need to solve this equation. So the factorial, remember the factorial means we just expand that number 5 like that. Same thing for down here. And 0 factorial is just 1. So we'll put a 1 in there for the 0 factorial. And we can solve this, and we don't have to multiply anything out because everything cancels, right? This is a 5 here cancels, 4 cancels, 3 and a 3, 2 and a 2, 1 and a 1. So that whole thing here kind of just reduces to 1. And then we have 1/2 raised to the 5th times 1/2 raised to 0, and this is going to be 1. And so then we're just left with 1/2 raised to the 5th. So we have a 1 out of 32 chance of all boys, of all the children being males. So the next question is 3 are males and 2 are females. So let's take a look at that. We can use the same formula now. So 3 boys, 2 girls. N is going to be 5. It's always going to be 5 because we're always we're working with a family of 5 children here. So 3 factorial for the number of boys, 2 factorial for the number of girls, 1/2 chance of having a boy, 1/2 chance of having a girl. And so if we were working with a different problem, right, if we were working with albinism and the parents were heterozygous, well then there would be a 3/4 chance of the children being normal, and they would have 2 big A's, or a big A and a little a, and a 1/4 chance of being albino. And then you would plug the 3/4 into the chance of being normal down here instead of 1/2 there, and then 1/4 for the chance of being albino. And then you would adjust these numbers accordingly depending to how many of each child you were looking for the particular family. But So that's just a little aside. We're not talking about albinism here, and that's why these probabilities are 1/2 and 1/2, because we're looking for numbers of boys and girls in a family of 5. So let's solve this. 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 for 2 times 1, and we can cancel out some of these, the 3's, 2's there, 1's, 1 doesn't matter really. And then we have 10 over 5 times 4 is 20, right? 20 over 2, and that reduces to 10. So this whole thing right here reduces to 10, or solves for 10, however you want to phrase that. Okay, so 1/2 raised to the 3rd is going to be 1/8, and 1/2 squared is going to be 1/4. So we are going to have, this is going to be 10 over 32, all right? 10 over 32, or 5 over 16. Okay, so the answer to that should be 5 over 16. So there's a 5/16 chance of having 3 boys and 2 girls in a family of 5. So the next part C is similar. So instead of 3 boys and 2 girls, we're going to look at 2 boys and 3 girls. And the idea here is that we're going to see that the ratio is going to be the same, right? Because you know, shouldn't well, for one, the formula is going to look identical. So 5 factorial over 2 factorial, 3 factorial, multiplied by 1/2 raised to 2, multiplied by 1/2 raised to 3. So let's take a look and compare. So I can copy and paste this and put them right next to each other. So this was the up here, this is the formula to part B. And paste it right below the formula for part C, and we can see that they're essentially the same, right? So we just switched the positions of the 2's and the 3's. So 2 here, 3 there, 3 there, and then 2 here, 3 there, 3 there. So the probability is going to be the same. 10 out of 32, or 5 out of 16 for 2 males and 3 females. And so what is the probability that all are the same sex? Okay, and this is a trick question, right? Okay, didn't we already answer this one? So the probability that all are males. Well, we decided that that was 1 out of 32. So isn't 1 out of 32 also the probability that all are the same sex? In this case, I think the question is trying to trick us, because we need to consider that all are boys or all are girls. So that's 1 over 32 chance of all being boys plus 1 over 32 chance all being girls. So that's 2 over 32, or 1 over 16. So 1 out of 16 chance that all are going to be the same sex.